Welcome to True Projects. In this video, we are going to explain about the project title Alzheimer's Disease Diagnosis, Innovative Detection and Classification based on MRI images. Before diving into the execution, let me give you an overview of the project. Let us first understand what Alzheimer's disease is. Alzheimer's disease is a brain condition that gradually decreases memory and thinking skills, eventually impacting day to day functioning. Significant memory concerns, SNC, one of the early indicators of Alzheimer's disease, may also be an indication of mild cognitive impairment, MCI. Since Alzheimer's disease has no known cure and treatment simply delays the disease progression, an accurate diagnosis is essential. However, evaluating a variety of medical data is necessary for Alzheimer's disease diagnosis, which burdens medical professionals. Traditional methods for diagnosing Alzheimer's disease, like clinical assessments, neuropsychological testing, medical history review, physical examination, brain imaging, and biomarker analysis, are essential for evaluating cognitive function and detecting brain changes. Yet, they are limited in sensitivity for early detection, accessibility, and distinguishing Alzheimer's from other conditions. However, recent advances in medical imaging, particularly magnetic resonance imaging MRI, provide a promising path to more precise and trustworthy diagnosis. In the base paper, the author has proposed the pre-trained convolutional neural network architectures, which are DenseNet, Inception V3, and ResNet 50, along with a custom built CNN for diagnosing Alzheimer's disease from MRI images. We have proposed exception model to further improve the performance for detecting Alzheimer's disease. The project utilizes deep learning models trained on MRI images to predict four categories: mild cognitive impairment, MCI, moderate dementia, non dementia, and very mild dementia. By accurately categorizing these stages, the system enables early diagnosis and intervention strategies for Alzheimer's disease progression. The project benefits patients, healthcare professionals, researchers, caregivers, families, and society by improving Alzheimer's disease diagnosis and management through accurate prediction of disease stages from MRI images. This increases patient outcomes, supports caregivers, advances research, and benefits society as a whole by reducing the burden of Alzheimer's and improving public health. To implement this project, we need software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, backend framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Algorithms used. These are the algorithms used in the project. The first four algorithms are proposed in the base paper, which are ResNet 50, Convolutional Neural Network, Inception V3, and DenseNet 201. This is the algorithm which we have proposed to further improve the performance for diagnosing Alzheimer's disease. We have built all these algorithms to compare their performance with different evaluation metrics like accuracy, precision, recall, and deafness score. And we will select the algorithm which is performing well. So exception model outperformed all other algorithms, and that is the reason we have deployed it in the front end. Let me explain you what exception is. Exception is a deep learning technique. It's known for being good at understanding images. It does this by breaking down the process of looking at images into two main steps. First, it looks at different parts of the image separately. This is called depth-wise convolution. Then it combines these parts to understand how they relate to each other. This is called point-wise convolution. This helps exception to understand images better and pick up on important details. One of its strengths is that it's really efficient at doing this, which is important when you are dealing with lots of images, like in medical analysis. Plus, it's great at figuring out what features in the images are important for making classifications. Another important thing about exception is that it can learn from other data sets before being used for a specific task. This is transfer learning. This makes it super adaptable and useful for projects like diagnosing Alzheimer's disease. Now, let us execute the project. To execute this project, first we need to open the code folder, which contains the project source code files. In this project, MRI images from the EDNI dataset are utilized. EDNI is Alzheimer's Disease Neuroimaging Initiative. These MRI images are employed for the development and evaluation of deep learning models aimed at diagnosing Alzheimer's disease based on neuroimaging data. In this dataset folder, we are having four different classes, namely mild demented, moderate demented, non demented, and very mild demented. In the mild demented folder, we have the MRI images of individuals diagnosed with mild dementia. So here we can see we are having total 896 MRI images of mild dementia. And in the moderate demented folder, we have the MRI images of individuals diagnosed with moderate dementia. And in the non-demented folder, we have the MRI images of individuals without dementia. And we are having a total of 3,200 MRI images of non-dementia. And here in the very mild demented folder, we have the MRI images of individuals diagnosed with very mild dementia. And here, this is the output folder in which we have the train and validation sets. The images from the data set of four different classes, that is mild dementia, moderate dementia, non-dementia, and very mild dementia, will be split into train and test, and those train and test folders are present in the output folder. So here we have the train and test. So in the train set, we have the images for all the four classes, which are mild dementia, moderate, non-dementia, and very mild. In the mild dementia, we have the images of individuals with mild dementia. And here we can see a total of 627. And since we have divided the data set into 80:20 ratio, so 80% of the images will be present in the train and 20 will be present in the test. So these images are used to train the models. And here in the moderate demented folder, we have the MRI images of individuals with moderate dementia. And here in the non-demented folder, we have the MRI images of individuals who do not have dementia. And here in the very mild demented folder, we have the MRI images of individuals who have very mild dementia. So all these images are used to train the models. And here in the validation folder, we again have all the four classes, which are mild demented, moderate demented, non-demented, and very mild demented. And in each of the folder, we have the MRI images with the respective dementia. So here we have the MRI images of individuals with mild dementia. And here in the moderate demented folder, we have the MRI images of individuals with moderate dementia. And in the non-demented folder, we have the MRI images of individuals who do not have dementia. And all these images are used to test the model's performance. And in the very mild demented folder, we have the images of MRI with individuals who have very mild dementia. And this is the static folder, which consists of files related to CSS, JavaScript, and Bootstrap. This is the sample folder in which we have the sample images of all the 4 classes. In the mild demented folder, we have the MRI images of the individuals with mild dementia. And here again in the moderate demented folder, we have the MRI images of the individuals with moderate dementia. And in the non-demented folder, we have the MRI images of individuals who do not have dementia. And in the very mild demented folder, we have the MRI images of the individuals who have very mild dementia. So we will utilize all these images during the execution. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file, which contains algorithm information which will be loaded into the project code during runtime. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. Here, I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, which is this, and localhost, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button here. So here we need to enter all these details to register. But I have already registered. So click on login here. So here we need to enter the username and the password which we have registered, which are static, and then click on login. We have logged in successfully and we are redirected to the prediction page. So here we need to upload the MRI scans, and after uploading the scans, the application will predict whether Alzheimer's disease is diagnosed or not. Click on choose file to select the image. So here from the sample data set, I'm selecting this image. Now click on open. So here we can see that the image is loaded. Now click on upload button. So here, this is the uploaded image and it is predicted as moderate dementia. Be more forgetful of recent events. Memory for the distant past generally seems better, but some details may be forgotten or confused. So here we have the general definition of moderate dementia. Now let us upload some more images. So now click on choose file. So here from the sample data set, I am selecting the image from the mild demented folder. Now click on open. Now click on upload button. So here, this is the uploaded image and it is predicted as mild cognitive impairment MCI. So here we have the general definition of MCI. MCI is a condition in which people have more memory or thinking problems than other people their age. The symptoms of MCI are not as severe as those of Alzheimer's disease or a related dementia. Now click on try again. Let us upload some more images. So here from the sample data set, from the very mild demented folder, I am selecting the 61th image. Click on open. So here we can see that the image is loaded. Now click on upload button. So this is the uploaded image and it is predicted as patients with very mild dementia may confuse objective cognitive impairments with subjective physical health of quality of life. So this scan is predicted as mild dementia. Now click on try again. Let us upload some more images. So from the sample data set, I am uploading this image from the non-demented folder. Now click on upload button. So here this is the uploaded image and it is predicted as non-dementia. That is, the patient is normal. Click on try again. Let us upload some more images from the sample data set. From the moderate demented, I am selecting this image. Now click on upload button. So here, this is the uploaded image and it is predicted as moderate dementia. And here, be more forgetful of recent events. Memory for the distant past generally seems better, but some details may be forgotten or confused. Now again, click on try again. Let us upload some more images. Click on choose file. Now let us upload the images from the train set itself. So here I'm selecting this image from the mild demented folder. Now click on upload button. So here this is the uploaded image and it is predicted as mild cognitive impairment MCI. So here we have the definition and the symptom for MCI, which is MCI is a condition in which people have more memory or thinking problems than other people their age. The symptoms of MCI are not as severe as those of Alzheimer's disease or a related dementia. Now click on try again. Let us upload some more images. So from the output folder in the train set, I'm uploading this image from the non-demented folder. Click on open. Now click on upload button. So here this is the uploaded image and here it is predicted as non-dementia. That is, the patient is normal. In this way, just by uploading the MRI scans, we can predict whether the person is diagnosed with dementia or not. So we are having four classes of dementia, that is mild dementia, moderate dementia, and very mild dementia, and non dementia. Non dementia is the person is normal. Now click on graph link here. So here we have the loss in accuracy curve of exception. So this is the loss curve of exception. For every increasing epoch, loss is decreasing in both training and validation. And here we have the accuracy curve of exception. And here for every increasing epoch, accuracy is increasing in both training and validation. And here we have the comparison graphs with different evaluation metrics: accuracy, precision, recall, and FN score. So this is the accuracy comparison graph. Here on the x-axis we have accuracy score, and on the y-axis we have algorithm name. Accuracy is a measure of how well a model correctly predicts outcomes. It represents the proportion of correctly classified instances among all instances evaluated. This is the precision comparison graph. Here on the x-axis we have precision score, and on the y-axis we have algorithm name. Precision is a measure of the correctness of positive predictions made by a classifier. This is the recall comparison graph. Here on the x-axis we have recall score, and on the y-axis we have algorithm name. Recall is a measure of the classifier's ability to correctly identify all relevant instances from a dataset. This is FN comparison graph. Here on the x-axis we have FN score, and on the y-axis we have algorithm name. FN score combines precision and recall into a single value. It provides a balance between precision and recall, taking into account both false positives and false negatives. The algorithm, which is performing well in all the evaluation metrics, will be used for prediction. Now click on sign out button here. So we have built a system that predicts whether Alzheimer's disease is diagnosed or not using the MRI images. We observed that exception outperformed others, and we have deployed it in the front end. In this project, we have utilized the EDNI dataset to take the MRI images from the EDNI dataset.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.